and this program kind of script series holds 3 programs. LampSpede, which calculates the response. If you know the irradiance of the lamp, it can calculate the response of the instrument for those irradiance files. Or if you know the response, you can set the response that, okay, I know that this response is right, and you can calculate irradiance for another lamp. Then there is RiskMaker, which take all the responses, for example, for a certain date, and calculates the average of the response. And it can also calculate the time series for the response. And then there is VW, which is just a tool for plotting. It has huge amount of different options you can give it, and even I don't know them all, because the script is written, and also part of the manual is written by Kaisa Lakkala, who really does all the lamp evaluation for soda and club brewers. So now we start with the known irradiances, and the programs work so that you always give them this initiation file. If I distribute to you this example, you can look into the initiation file. It's rather long, and I don't want to go through all the steps now. But if you want to make your own lamp response time series, I can come with you and show you all the steps it has. But in this first one, we initiate the program so that it only uses this date, where we know that we have measured all these 4 lamps we are going to use in this example.
What do you mean by this date? 16.5.
This is the day of year.
Yeah. Day or what?
The number of the day.
Yes,
so from the 1st of January. So
okay.
1st of January is 1, and this is the year in two digits. So
but I'm wondering here that you are taking the Julian day at 600.
Sorry?
Your Julian day here is 600.
Yeah, this is
From the starting of the brewer working or what?
No, this is not what I run. I have been running this before, earlier today. Okay, so now I'm in the folder. It gives out this, and now it has calculated the response for these 2 lamps. We have the irradiance files for
The primary lamps.
and now we can now with the plotting software we can check what it looks like. It of course throws them to the wrong monitor, but so these are the two responses it calculated for the 2 different lamps. You can see that they are not exactly the same.
This is 1000 now.
Yes,
Okay.
they are both 1000 watt lamps. And now we use the response maker to calculate average response of these 2 from these two lamps for that certain day. And unfortunately, I don't know why they have excluded this option, but I cannot block this one, at least with this program. Of course, it is in a file, so if you have MATLAB or anything you use, you can block the file. And now, using this response, we will calculate the irradiance for these two other lamps. And with the plotting tool, they go in the folder irradiance/transfer. They look like this. So now these are the secondary irradiances we calculate using the response from the lamps we get from the Meteorology Institute. And now we can use these as irradiance for these two lamps to calculate the response time series. We need some hand editing, so they go here. I have made the initiation file for the next step so that these need to be renamed and moved here where we had the original two irradiances. So we rename them with the same idea as the others, so lamp equal to 2. We can put here some specification that we then later remember that what is this irradiance file, because we don't want to mix them with the primary ones. So we put cal 07, so luckily, if we're lucky, we remember later that okay, these have been made with the irradiance scale from the primary ones, 2007. And there are also the first two lines are now different than with these ones. So the first line, according to the program, so that it can read it, has to be within this format. Here we need to have the lamp number, and the second line tells us how far it should be from the diffuser. I think this is the distance that they use for calibrating it at the Meteorology Institute.
Yeah.
Save that. Also, other one. Okay, now we have 4 irradiance files. We can now use these to recalculate all the lamp measurements we have made during 2007 and 2008, which we have the data for. there's something wrong. This is not good. Let's see. Yes. I did.
But maybe it's correct. I was a bit confused.
Ah. Mrs. Key.
Yeah.
And the other one.
Also on the other? No, it's lamp D24. Yeah, okay. Let's try again. This one? It's some kind of, I don't know, it's something that Linux does, some kind of backup. I don't think it uses that. I don't. Okay, now it processes all the lamp files we had, and then we can check out what it did. They went to this folder. All the output folders are in the initiation file. So when you get this example, you can look what the initiation file has in it, and you can change the folders. If you change the output folder, it always creates a new folder if the folder does not exist. So
And you use the same response file with the
we have now the
different UL file?
we use the same irradiances for all these.
Sorry, the same irradiance.
Yes,
okay.
yes, we use the same. So, well, let's look further. So, okay, this is what we get. This doesn't help us a lot. This is all the responses plotted on top of each other. So, you can't really see a lot from this one. But then you can plot just a single wavelength. Yep, so here we can see how the response has behaved during this time with the wavelength of 311 nanometers. You can pick other wavelengths also and check if 320 behaves differently. And now we can see that, for example, lamp D25 has started somehow, the intensity has been decreasing with respect to the other lamps. So we think that, okay, maybe this lamp is getting old or something. And we want to take out all the measurements from this measurement on. So we keep this one, but we want to take all these out because they seem to be outliers. So we can create a blacklist and put in the initiation file that, okay, we want to use this blacklist to block out some measurements. I can show the blacklist. Just a text file giving you which response is not to use. And it's already included in this initiation file, step 8. So we use that one, and it recalculates all the lamp measurements, but it now leaves out the D25. So okay, we could check this again, but it would just show us all the responses on top of each other, so it's hard to pick anything out from that. So let's just take the specific wavelength. So now we can see it has left out the measurements we didn't want in our response. Okay, this looks like an outlier also, but let's just leave it be. And now the last step, we now have in blacklist all the stuff we don't want in. We can take the rest maker again, and in the initiation file you can set that do you want to make a time interpolation, just put in, there's an n, put in y, and it will calculate the average of the lamps and then interpolate between the times you don't have, because you don't of course measure the lamps every day, you measure it every 4 or 6 weeks, so it interpolates those timer intervals. We have between the first and the last day there are 662 days, so it's 2 years of data. And now if we want to include in the plot the time series it calculated, we need to put it because it seems that this plotting program, if you put here response, it reads it from response history folder. So you need to have this folder and put all the data, it just calculated. So it's in this response / time interpolation. We have, for each day we have a UVR file. So we copy them and move in the response history, hopefully. Yep. And the last thing is to check what it looks like with this one wavelength. Okay, so it uses some kind of polynomial fit, so for me it doesn't look very nice, but this is what we get from using these lamps and interpolating between time. This is the response for this particular wavelength. And of course we can check other wavelengths. We can just change this. Let's put in here 15. The wavelength is in angstroms, so you have to take the nanometers and multiply by 10. But as you see, the shape seems to be pretty much the same.
What kind of interpolation you use?
I think this is some kind of polynomial interpolation. Yes,
okay.
because it makes these annoying bumps every here and there, so maybe we could use something else.
I think it's not, maybe it's not polynomial. I think it's just a drifting window.
Ah, okay. Yeah, can be.
But I forgot how wide.
I think it's actually 29 days. You can actually adjust you can adjust the window in the initiation file of this of the program.
What is
So
the
you can
unit
try.
of the response? What is the unit of the response? Does that count?
It's also in the list. Let's see. Where's the mouse? Let's take one of the. So here's an example of an initiation file. You have instrument number. I can see that this example is for 107. I'm using the data from 037, so this should be changed if I use this. Also the instrument type, so 107 is a double. Remove all the results. Where are the raw files? The blacklist, name of the file. Where to take the irradiances. The unit of wavelength. Temperature, circuit type. There are a huge amount of settings you can put up. Here you can set if you want the irradiance. If you know the response and want to have the irradiance, put here yes, and you need to put no where it says that do you want to make the response. Here. So if you want to calculate the response, you put here yes and irradiance no. And if you know the response and want that irradiance, vice versa. And here is the unit. So response unit has been set to, so it counts per milliwatt per square meter per nano.
Okay, thank you. Can you put your data on the meeting server in the shared folder?
Sorry?
Can you put your data in the meeting server on the shared folder so we can download it along with the Perl scripts?
Yes, I think I can put I have this clean example file which you only have the irradiances and some of the lamp and the lamp files.
Yeah.
And you need to, if you want to see the whole stuff, you need to run the Perl
Yeah,
scripts.
but I will run Linux as well. So you
Yes.
can upload the
Yes.
Perl scripts as well?
Yep.
I should just take it down.
Yes.